Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, hosting theCUBE here with Dave Vellante, my co-host.
Welcome to the Raise Summit coverage, brought to you by Solidigm, with support from Tensordyne, D-Matrix and Argentum.
Welcome to theCUBE, everyone, live streaming here in Paris, France for the Raise Summit. This is day one kickoff. We had day zero yesterday, Machinist Summit. It's the physical AI and robotics, kind of a sidecar event, but as that growth continues, the main story is the growth of AI here at the Raise Summit. Action-packed house here with all the top leaders in the global tech scene, certainly with AI driving. We're kicking off the show with Greg Matson, Senior Vice President, Head of Products and Marketing at Solidigm. Greg, great to have you on, and thank you guys for sponsoring theCUBE. Really appreciate the support, and again, the success of Solidigm continues. I know you guys, the demand curve's crushing it, so welcome back to theCUBE, great to see you.
Well, first, it's great to be here at Raise, right? It's our first time being at Raise, and I can't believe the collection of leaders from across the AI landscape, so it's very exciting to be here.
You know, it's really exciting for me, been following you guys, been following the growth for many, many years now, and the past 2 years in particular, what you guys have done on the product side has been incredible. You know, I've always been kind of falling over myself looking at how small and how performance the drives are on the SSD. But last night at the Versailles event, I mean, everyone was clamoring on, give me some product. You guys are in high demand, and I think if you look at what NVIDIA and all this large scale AI factories is, the AI growth is a completely new infrastructure build out, and the AI growth here at the Raise Summit, Mark Cuban was just on stage, they're talking about Lovable, and all the apps are coming in, and the power of the infrastructure is really enabling that, but the density, which used to be, oh, there's too much dense equipment on the board, is actually a feature because they want to get the components together, and you guys have had a great product. So talk about that dynamic, one, the demand, and two, how the infrastructure has changed to get this high performance, supercomputing capability.
Yep, absolutely. I mean, first is, you're right, the demand is exploding. I mean, it started a couple of years ago with training, where the need for high capacity, high performance storage, very adjacent to the GPUs, was all of a sudden, you know, on stage, right? We needed as high capacity as we could get. But now at the inference, you know, as we go in last year into this year, inference phase into agentic inference, it's exploding even more. And where you're talking about, you know, the inference, basically blowing out of the HBM and the DRAM footprint, needing to be extended into storage, and now storage is actually, a whole new storage tier is being created to extend the memory of the system. And that memory is really where the data is being housed, that's being worked on, and that's taking that data and turning it actually into the intelligence. So I almost call it the intelligence layer is now being housed on storage.
And I bring up the density thing because the market's flipped, it's inverted now. It's you're seeing a whole different paradigm of engineering. We've been talking many times on the CUBE pod about, you know, Windows and Intel, and during that era of the processor advancements that powered the PC revolution, it was always that operating system that brought the applications in. So Windows had applications, and what we're seeing now with AI is that those large scale AI factories and now the enterprise clusters have to have that power. So every year we're seeing more and more functionality from NVIDIA, but what's interesting is that it's not the PC era, it's the supercomputer era. And Solidym's at the center of it because there's no more hard disk drives anymore. That was the old era.
That was old days.
The SSDs have grown in and they play a critical role because now you're seeing desktop computers that are AI enabled. Again, servers first, systems first, now desktops. You guys are the key element. Explain that nuance because SSDs and high bandwidth memory work together. They're not just like, hey, there's memory in a hard disk. Talk about the dynamic.
Definitely the era of memory and a hard disk is over in AI, right? Because that HBM needs an extension, right? It needs to be fed continuously with a lot of data. And high capacity SSDs are really what's coming into play, you know, over the past couple of years. It was 30 terabytes, it was 60 terabytes, it's 122 terabytes per drive. Now you have a system full of drives, a rack full of systems, and you're talking about petabytes worth of storage per GPU cluster. And that's really to make sure that you keep your GPUs fed. And while the GPU is the most expensive part of your infrastructure, you want that thing to be humming 100% of the time, generating tokens. And if it's down, right, waiting for data, then you're wasting your money on GPUs, and it's just much less efficient without that high capacity storage right next to the GPU.
It's funny, I was talking to someone yesterday, they're like, yeah, you're seeing the models, OpenAI, Anthropic, you're going to start to see the performance. If you're waiting, it feels like dial-up internet. It's like, so speed is critical, and if you look at storage, I was talking with Vast Data as well, the storage equations, they don't even call themselves storage, they call themselves a data platform. So the data layer for inference, context windows, the things that are powering Replit, all these apps, have to have that high performance. Talk about that dynamic, because you guys sit in the middle, you guys enablement, what are you guys doing today in terms of product? What's coming down the pike? I know the demand curves, there's a line around the corner for product, but the storage equation's changed. The people that you sell to and you're embedding into, these are large scale systems that are powering the performance of AI.
The demand scale is for sure changing, and we can look out as far as we can see, and we have demand. And I think that's the same for anyone in this AI infrastructure space, right? The infrastructure now is really the asset that's going to power the AI revolution.
Talk about the enterprise too. The enterprise is a new thing this year, not new, but the crossover from hard disk drives to SSD, but also the configurations on premises. And certainly here at Raise Summit, sovereignty is a huge issue. So you start to see these new deployments. Can you share any commentary on how those are going, how you see those happening?
Well, first is the problems or the challenges from an IT infrastructure at scale, at the hyperscale level, and out at the edge, at the enterprises, are the same. They need high capacity, they need high performance, in a space efficient, power efficient footprint. And high capacity SSDs are really the only way to get that at the storage layer, or as Vast talks about it, the data layer, and I even call it the intelligence layer, because you take that data and process it and turn it into actually your information.
When you have conversations here at Raise and around the industry, what's the current state-of-the-art conversation right now? What are people asking you for? What is the top of mind concern, opportunity?
Well, of course, allocation, right?
We saw that, you got mugged last night.
Yeah, it was pretty good. And it's nice to be there, right? Because memory and storage has a lot of times been the afterthought. Now it's really the forethought, because people are realizing that AI is data, right? That is the key. And data is housed in storage, and it's worked on in memory. And that's really why people are really starting to think about those two things, first, or at least in parallel with their GPU and their system decisions.
There's a big conversation, liquid cooled has been super hot, and most people think it's for large scale systems. You guys have pioneered that one piece. Outside of that, talk about the product mix. What are you seeing there in terms of deployments?
Yeah, first is liquid cooled. We did introduce the world's first liquid cooled SSD and continue that development as we see NVIDIA especially pushing out completely fanless systems. And so every component within the rack will be liquid cooled, whether it needs to be or not, because they want to reduce the power and the space associated with the fans. And that's actually great for the data center environments, because it also creates a new level of efficiency and environmental friendliness in terms of water consumption and things like that, and power consumption. It also allows us to run at way higher performance levels, and at a higher power per unit, but higher performance overall at the system level.
All right, this year at the Raise Summit, I'd like to get your take on what's your current vibe. I mean, obviously sovereignty is a hot conversation. What that means is people are building out essentially large scale infrastructure in regions and countries, and enterprises have sovereignty. What does that mean for folks? And what do you think the top story is so far at Raise? What's coming out of the current show format right now for you?
Well, first is day one in the morning. But I think sovereignty is important, right? We talked to a lot of people already last night and today from different parts of the world, all interested in the very similar things, right? Building their own infrastructure in the most efficient way, state-of-the-art way possible, I think is still really the thing that we've heard so far. And
performance-wise, what are you hearing for people asking for performance? Where's that puck going? How do you see that playing out?
Well, on the SSD side, we're going for PCI Gen 4 to Gen 5 in the high capacity storage space. And then from Gen 5 to Gen 6 as the Blackwell systems move to Rubin systems, and that's really for the direct attach SSD space. So really, performance is key, capacity is key, but most importantly, supply and availability is key.
Yeah, so you're very popular. What are some of the cloud dynamics? You got the hyperscalers, the NeoClouds, and the enterprises all booming right now in terms of build out. What are some of the trends you're seeing there?
Some of the things, so the hyperscalers had massive amounts of storage infrastructure that already existed for traditional compute. What they found is, about 12 to 18 months ago, they're like, hey, this doesn't keep up. And so they're really doing something they hadn't done in a long time. There's rip and replace going on in terms of the big storage infrastructure. And that's something that, really they had been letting assets run for as long as they possibly could. And we have some drives that have been going on, in production for more than 10 years. So now they're deploying modern storage, high capacity storage, and we're really seeing this high capacity adoption across the board with the hyperscalers, also with the NeoClouds, also at the edge. So it's really a very similar thing across the span of customers.
Price performance has always been a benchmark in technology, hardware, software. Now you got token costs, these are now new economics.
Yep.
How are you guys looking at performance and price on the SSD side, and how does that translate in your mind to some of these token economies that are developing? Because tokens are the new currency in AI, that's now got a performance element and cost to it. Talk about the price performance dynamic that you guys are constantly iterating on.
Well, we have, of course, prices are going up. It's great for us. Historically, it's been a challenge sometimes to invest in the capital infrastructure that you need to build out SSDs. Now it becomes affordable, it's becoming essential infrastructure for AI, and it's also essential for making those tokens more and more affordable as you're building an AI factory to generate tokens. So if you're waiting on data, then you're not generating tokens. And even a simple 15-word prompt can generate as much as 40,000 tokens through the context of that entire prompt. That's maybe 5 to 10 gigabytes of data. Think of that's one person's simple prompt, and now you go, okay, I have X number of employees using Y number of agents, and you can go quickly into the petabytes worth of just context storage. And so needing that high capacity and high performance storage actually improves your token economics and lowers your cost of tokens and improves the overall token output in your factory.
It's funny to see. I brought up the PC revolution because I think there's a very comparable where you had that hard disk drive, it was separate from the processor.
Yeah.
Today the processor is GPU, HBM memory, SSD. It's kind of a new architecture that's actually one thing. You mentioned context window. You look at KV cache, for instance, with NVIDIA. These networking have to move the data to the GPU as fast as possible. So in a way, the SSDs are becoming the processor by default because they have to be right there. They can't be slow, they got to be tight.
Right there and on and ready to go.
Yeah.
Right? So high performance, available and high capacity to make sure that you're having all that data very adjacent. I mean, you think about, if you see a book, there's data over here.
Yeah.
You read a book, that starts to become information to you.
Yeah.
You think about the book, you talk to somebody about the book, now you're creating intelligence around that book. That's exactly what's happening at the inference layer, and you need to have that data, basically the GPU and the data become now a seamless system, through.
And you're seeing out here the examples, the enablement of making that work powers the AI revolution. And I think that's a story people are starting now to understand. How do you explain all this when people who aren't in tech in your family or friend group, like, hey, Greg, what's going on with all this AI stuff? Well, how do you explain it?
Well, I mean, partly, a little bit that's why I brought up the book analogy, because it's something that anyone can think about, or anyone can relate to. I try to liken it back to the cloud era. So if you go back into the beginning of the internet era, maybe late 90s, early 2000s, and that was the time when infrastructure started to be built for the internet, but the internet didn't really bud until, for decades, it's been building out, and now everyone's life is online. And that's where we are kind of at the AI infrastructure time frame, is we're here, it sounds like big business, stocks are going crazy, revenues for everyone in the hardware business are going crazy, but it's just the beginning. Yeah. And so it's just the worldwide accelerated compute infrastructure build out is just in its infancy.
It's a whole new architecture. I was talking last night about just the 5G build out. Just think about this, 5G, we know our phones, 1G, 2G, 3G, 4G, just 5G telecom, close to $1 trillion just on that.
Wow.
If you look at the totality of just 3G to 5G, it's trillions and trillions of dollars. And people kind of scratch their heads like, whoa, so much money's being spent on AI. These are new roads being paved. This is concrete being poured, metaphorically, so like a whole nother generation of architecture. This isn't a data center refresh. This is a whole nother thing.
Brand new, from the grounds up, built for acceleration.
And you guys are, and how are you guys designing into that? Continuing to get closer to the chips, working on density, smaller form factors, edge, share the little
all
roadmap.
of it. So we start at the silicon level. So we, each memory chip has to get denser, smaller in terms of bit density, and so we come out and have a very fast cadence of new memory chips, but then we build those into SSDs. Yeah. We've been engineering at the package level, so we stack a lot of those chips into one package. We try to make those as small as possible and stack as many as we can in each package. Yeah. And then at the form factor level, there's different form factors for different chassis designs as well as different interface speeds of the drive. So we have to actually fan out our amount of form factors. Yeah. And then, of course, there's air-cooled and liquid-cooled form factors.
I mean, you can't even call them drives anymore because the crossover from hard disk drive to SSD makes it memory based. It's memory.
Yes, it's memory.
And so you guys are the inside power engine for the inference era of AI. I mean, Solidigm Inside is what's powering this whole generation.
Absolutely. The inference layer is the data layer is the storage layer. I mean, that's the Solidigm layer.
Infrastructure is the new killer app. Okay, just let's end up by talking about some of the partnerships. Just share the relationships you guys have. I mean, you're working with everybody. Just talk about some of the big names.
Yeah, first is, there's, it's pretty public. Today you'll see me on stage with Vast Data, one of our great partners and great winners in terms of AI infrastructure storage. We partner with all the different ISVs though, WEKA, MinIO. We have big customer relationships with the big hyperscalers that you can imagine, both in the US, but also globally. So we want to make sure that we're partnering with the NeoClouds as well. Yeah. We've been on stage a lot with CoreWeave, so there's the one a lot of people know, but many, many others as well.
And the liquid cool gets you into the big systems too, because everything on the high end is liquid cooled.
Oh, everything's coming out, as we go in the next couple of years, nothing will be air cooled.
Yeah. Well, great design. You guys have love that form factor. I first saw it, I remember saying, that's not real. I can't believe that's going to happen. Congratulations.
Well,
thanks for coming on theCUBE.
Thanks, John. Appreciate it.
All right. Solidigm powering the next generation, Solidigm Inside, the AI factories, and all the AI growth that's happened. It's just the beginning. I mean, the roads are being paved, concrete's being poured of the AI infrastructure. These data centers are expanding to the edge as well. We're going to do our part here on theCUBE to cover it. I'm John Furrier, your host. Thanks for watching.